Okay, so we will do another example on a line integral. And the question is to evaluate this line integral x y squared ds on a curve C, where C is defined as the right half of the circle x squared plus y squared equals 4, oriented counterclockwise, which is the positive orientation for line integrals. So if we were to illustrate our curve C on a xy plane, C is the right half circle with radius 2. And so usually when we have circles, first of all, we need to parameterize the curve in order to evaluate the line integral. And usually when we have circles, the easiest way to do this is to parameterize the curve with sines and cosines, because the sum of the squares of sines and cosines will conveniently get you the required radius. So x is 2 cosine t, y is 2 sine t, which when you square both sides and add them, you get exactly the equation of the circle x squared plus y squared equals 4. That's why this parameterization is very convenient and straightforward. So now we can rewrite our ds, which is the length of our curve C, as dx over dt squared plus dy over dt squared, and we will take the square root of that thing. And so dx over dt will become minus 2 sine t, that's the derivative of x, and dy over dt is 2 cosine t squared and square root. And of course, when you square them and add them, you will get 4 times sine squared plus cosine squared, which is 1. So you get 4, square root of 4 is 2. So now we substitute in the line integral, and we get x to be 2 cosine t, and y squared is just 2 sine t squared, and ds turned out to be 2, and of course we have a dt. And since t here represents the angle, and we have the right side of the circle, our theta, or t in this case, will go from minus pi over 2 to pi over 2, and those will be our lower bounds and upper bounds, respectively. Let's go ahead and evaluate this on the next page. So if I were to move this here, we will get so far we have 4 times 2 is 8. I will pull this out, and then we have sine squared t cosine t dt. And of course, this is a relatively simple integral. If we make the substitution of the u substitution with sine t being u, that works out just fine, because the derivative of sine is cosine, and that's conveniently located inside your integral. So then we would get du to be cosine t dt. So this line integral becomes 8 sine squared, which is u squared, and cosine t dt is just simply your du. So this becomes 8 u cubed over 3. Now we put the u back, so we have 8/3, and u is sine, so this is just sine cubed t. And now we can evaluate from minus pi over 2 to pi over 2. So this becomes 8 over 3 sine cubed, upper bound first, minus lower bound next. Now, sine is an odd function, which means sine of minus theta becomes minus sine theta. And the 3 will keep the negative and negative. So we would get here 8 over 3 sine cube pi over 2 plus, because the minus next to the pi over 2 and another negative sign here will make this a plus, sine cube pi over 2. And sine pi over 2 is 1, so when we cube it, it remains 1, and we add it to another 1, so we get 2 here. So this simply comes down to 16 over 3. Please don't forget to rate, comment, and subscribe. See you later.